All right, so for this first problem here, we want to start off figuring out what the parent function is. So the parent function here is y equals x cubed. So we can draw that first. That's our cubic squiggle. It goes through the 1, 1, and 0, 0. Does the same thing over here on this side, so if it's helpful, you can put another point there. And then the minus 3 is just going to tell us to go down 3. So then to write our final result, we'll just move all the points down 3. And draw our result. So this will be the answer in red. For number 13 here, our parent function, you can see the squared here. So that's going to be y equals x squared. So x squared is our quadratic, so it looks like a U. So that's our parent function. The 2 on the outside is going to tell us about up and down y values, right? So we're going to multiply all the y values by 2, so that will be a vertical stretch of 2. And then on the inside, this subtraction is going to be the opposite. So we would think normally that would mean left 2, but it actually means right 2. Remember, inside is always left and right because it's x values. So let's start with the vertical stretch. So if I pick my point 0, 0, and I do the vertical stretch, I'm going to multiply all the y values by 2 because the 2 is on the outside. If I multiply the y value here by 2, 0 times 2 will not be 2, it will be 0, so it doesn't move. Then we have to move it right 2. So first it will stay in the same spot from the vertical stretch, and then it will move right 2. So that 0, 0 point now moves there. So now let's take the point 1, 1 and move it. If we move that with a vertical stretch, we're going to multiply the y values by 2 because the 2 is on the outside, so it'll be 1, 2 when you multiply 1 by 2. So this point that originally is right here, we'll move to 1, 2, which is right here, but then we still have to move it right 2, so then we'll go right 2, and this is where it will end up. So this is the right half of our parabola, and then you have the mirror image on the other side. And that red graph is our answer. For number 14, our parent function here is going to be the cube root of x. We can see that because we see the cube root here. And this minus 2 on the inside is going to tell us about left and right because it's on the inside. It will be the opposite, so we'll go right 2. And the plus 4 on the outside is going to be up and down, and it will be exactly what we think, up 4. So first let's draw the parent function, the cube root function. It looks a lot like the cube function, it's just on its side. So it's a squiggle on its side. If you want an extra point here, you can look at the same thing on the other side. And we just need to move this right 2 and up 4. So we'll start with the point at 0, 0, move it right 2 and up 4. And then do the same thing with the point at 1, 1, right 2, up 4. And if you want to move the other point as well, right 2, up 4, if that helps you see what's happening. And then we draw our answer graph. All right, for some number 15, we're going to first find our parent function. Here, that will be y equal absolute value of x. You can see the absolute value in there. The minus in front, that's a negative on the outside, so that's going to change our our y values. It will change our y values because it's on the outside. Outside is always y, which will cause us to reflect over the x. And then the minus 4 on the outside will tell us to go up or down. It's exactly what we think. It is down 4. So we'll start by drawing our parent function. Absolute value is your v. If you want to draw another point on the other side, it definitely goes through 1, 1. So let's start with moving the point 0, 0. So we'll start with our reflection over the x-axis. Remember, it's on the outside, so we're going to change the y values, change their sign. Now, the y value of 0 is 0. The y value here is 0, and that does not have a sign, so that's not going to change. It will stay 0, 0. And then we're going to go down 4. So let's go ahead and move that point. So it stays the same for the reflection, and then goes down 4. Now let's do the point 1, 1. With the reflection, remember reflecting over the x-axis, we'll change the y values because the negative is on the outside. So the one that's a y will now be a negative 1. So the point that was at 1, 1 will now be at 1, negative 1. So that's right here. And then we still have to move it down 4. 1, 2, 3, 4. So when we reflect over the x-axis, remember that's this axis right here, that flips the v upside down. So we can see that this is now our v, is our answer. All right, for number 16, we want to find our parent function. We can see the squared here. That tells us our parent function is going to be y equals x squared. The 2 here is on the inside, so that's going to be horizontal stretch or compression. And remember, it's the opposite. So this will be a horizontal compression of 1/2. And then the 5 tells us to go up 5 because it's on the outside. So we start with graphing our parent function here. That's x squared, goes through 0, 0, and 1, 1. If you want to draw another point on the other side, it does the same thing. Let's start with the point 0, 0. We'll do the horizontal compression to it. Because it's on the inside, you're going to do it to the x values. So you can think about either multiplying the x values by 1/2 or dividing by 2. That's the same thing, multiplying the x values by 1/2 or dividing by 2. So if you take your 0 here and multiply it by 1/2 or divide by 2, either one, you're still going to end up with 0. So 0, 0 doesn't move from the horizontal compression, but then we still have to go up 5. So now it will go up 5. Now let's move the point 1, 1. So the horizontal compression, we're going to multiply the x value because it's on the inside. We're going to multiply the x value by the opposite, right? So 1/2, because the horizontal compression, multiply the x value by 1/2 or divide by 2. So that'll be 1/2 for the x value or 0.5. So my point that was at 1, 1 is now at 1/2, 1, which is right there. It's a little hard to see, but then we still have to move it up 5. So it'll be right here when we move it up 5. If it's hard to see a point like that, you could also use the point 2, 4, which is also on the parabola because 2 squared is 4. And if you move that point instead, you're going to multiply the x value by 1/2 or divide by 2, and that will be 1, 4. So you could also put a point at 1, 4, and then move it up 5. So it would here. So if you want to do another point there, that would be another point to do. But it's going to make this really narrow. So we either need to have a point here or here on our answer. All right, for this graph here, our parent function is the square root of x. The negative on the inside is going to change our x values, so that will reflect over the y. And the -1 will take us down 1. So we'll start with our graph, the square root. That's this 1/2 of a sideways x squared. It goes to the point 0, 0, and 1, 1. So let's first start by moving the point 0, 0 when we reflect over y. Remember, the negative is on the inside, so we're going to change the x values because it's on the inside. The x value here is 0. It doesn't change sign, so it will stay the same with the reflection. And then we still need to move down 1. So take 0, 0. It stays with the reflection and then moves down 1. Now let's take the point 1, 1 and reflect it over y. So you can either reflect it over the y-axis and realize it needs to go there, Or you can change the x value because it's on the inside, right? So we'll change the sign of the x. So it'll be -1, 1, which is exactly where we had it right there, -1, 1. So the point at 1, 1 goes to -1, 1, but then we still have to go down 1. So when we reflect over the y-axis, our arrow is going to face the other direction. So that's why it goes through that point like this. And that's our final answer. All right, for these questions here, we're writing an equation of a parent function so they're describing it and we're writing the equation. So the cubic parent function is y equals x cubed. And then we want to go 3 units to the right and 4 up. So the right will be inside. And remember, it's opposite, so we'll say -3 to make it go right 3. And then the +4 will go on the outside because it's up. So this will be our answer. For the next problem, we want a quadratic parent function. So that's y equals x squared. We want to go left 2 and 3 up. So the left will go on the inside. It will be the opposite. So we'll do +2 to go left 2. And then 3 up will go on the outside. And then for the last one, we want the equation for the square root parent function. We want to go right 14 and down 15. So the 14 will go on the inside. We want it to be the opposite. And the 15 down will go on the outside. All right, now for factoring, this one here is a difference of 2 squares, or dots. Difference of 2 squares, because 1 is a perfect square and x is a perfect square. So this is pretty easy to factor. You know it's going to be x and x, because x times x is x squared. And then it's going to be 1 and 1, because 1 times 1 is 1. 1 will be plus, and 1 will be minus. The next one here is a trinomial where a is 1. So we're simply going to look for 2 numbers that multiply together to get 8 and add together to get -9. There's quite a few numbers that multiply together to get 8. There's 2 and 4, and 1 and 8. Now to multiply together to get a positive, but add together to get a negative, that means both of our numbers are going to have to be negative. Because to multiply together to get a positive, they're either both positive or both negative. And we want to add together to get a negative. So if we make both the 2 and the 4 negative, add those together, we get -6, but we want -8, so that doesn't work. But make the -1 and the 8 negative, and add those together, and we get -9. So then we just get to factor this. We know the front will both be x and x, because that's just x squared, and we know it'll be -1 and -8. Number 3 is a difference of cubes, because 27 is 3 cubed, and n is cubed. So we're going to go over here to this formula here. We need to figure out what a is and what b is. So for a, you want to ask yourself, what's being cubed? So n is being cubed in the first part here. So that means a is n. And in the second part, the number that's being cubed here is 3, because 27 is 3 cubed. So b is 3. So then we want to use the formula and write down our factors. So it'll be a minus b, so n minus 3, a squared, n squared, plus a times b, so 3n plus b squared is 9. So for number 4, here a is 1. So we're simply going to look for 2 numbers that multiply together to get 33 and add together to get 14. 3 and 11 are one combo that add together to get 33. And I think that's pretty much it besides 1 and 33. And 3 and 11 clearly add together to get 14. So those are our numbers here. So it's going to be g plus 3 and g plus 11, because this is g squared at the front, right? So we know that has to be g and g. Number 5, this also is a is 1. So we're going to be looking for two numbers that multiply together to get negative 26 and add together to get negative 11. Well, two numbers that add together to get, or multiply together to get 26 is just 2 and 13, besides 1 and 26. And 1 and 26 will definitely not add together to get negative 11. Now we're multiplying together to get negative 26, so one of them has to be a negative. If I make the negative for the 2, that'll give me positive 11, but I want negative 11. So I want to put the negative with the 13. So then the factors will be v and v, because it's v squared, and then minus 13 plus 2. For this next one here, number 6, here a is 1. So first we should check to make sure we don't have a GCF or a greatest common factor, but 22 is not divisible by 3, and not all of them have an a, so we don't need to factor anything out to start with. So here a is not 1. So remember, the first thing we're going to do here is multiply 3 times negative 45. So if I multiply 3 and negative 45, we get negative 135. I'm going to move some of this out of the way here. So we'll get negative 135 when we multiply 3 and negative 45. So we're looking for two numbers that multiply together to get negative 35 and add together to get 22. These are some big numbers, so we're just going to have to check some numbers. So let's start with dividing 135. It ends in 5, so it's definitely divisible by 5. So let's try that. 35 is divisible by 5. So let's check 27 and 5. Now one of them has to be negative because the 135 is negative. If you multiply two numbers together to get a negative, one has to be negative. If we make the 5 negative, 27 minus 5, will be 22. Look at that. We got it on the first try. So now remember, we're going to replace this middle term with those numbers. So we're going to copy down 3a squared, replace 22 with 27a, minus 5a, and then we copy our 45 down. You could use slide and divide here if you want. That's fine, or guess and check, but this one's a hard one to guess and check because they're big numbers. Now we're going to do our factor by grouping. So we're going to look here on the left for a common factor. They definitely both have an a in common, and 27 and 3 are both divisible by 3, so our GCF is 3a. When I factor that out of this first term, I'm left with just an a, because that had an a squared to start. And then 27a, when I pull out an a, there will be no a. 27 divided by 3 is 9, so it'll be plus 9. Now on the right-hand side here, 45 and 5 are both divisible by 5, and because there's a negative in the front here, we're going to pull that out with the 5. So we're going to pull out a negative 5. So the first term here will be left with a, and when we do negative 45 divided by negative 5, we'll end up with plus 9, which is good because that matches over there. So then we'll know one of our factors is a plus 9, that common factor, and then the other factor is what's left, the 3a minus 5. And so this is our answer here. All right, let's go up here to number 7. Here we have 4 terms, so we know we're going to factor by grouping. We could check for a GCF first, but there isn't one here. On the left-hand side, we have a y cubed and a y squared, so the greatest common factor is y squared. There's no number. When I pull that out of y cubed, that's 3 y's, so now it leaves me with 1 y when I pull out a y squared. When I pull y squared out of the second term here, that leaves me with a minus 3. Now if I do that on this other side here, 4 and 12 both have a common factor of 4, so I'm going to factor out of 4. That has a plus in front of it, so I'm going to keep that plus in front of it. And when I divide 4y by 4, I'm left with just a y. When I divide negative 12 by 4, I'm left with minus 3, which is good because what's in the parentheses matches. So that's going to be one of our factors. And the other factor will be what's left, y squared plus 4. and that is our answer here. This next one, we're also going to do factor by grouping. Because there's 4 terms, so we're going to put a dotted line down the middle. We'll look at our first 2 terms over here, look for our common factor. They both have 2 q's at least, right? Because there's a q squared and a q cubed. So we're going to factor out a q squared. When I pull that out of the first term, I'll be left with 1 q left. When I pull that out of the second term, I'll be left with just a -2. On the right-hand side, 16 and 32 have a common factor. They're divisible by 2, but that's not the biggest one. Remember, you want the greatest common factor. The greatest common factor is 16. They're both divisible by 16. And because this 16 has a minus in front, remember you want to pull that out with the -16. So when I factor out -16 out of this first part, that'll just leave me in with a q. And when I factor -16 out of 32, we'll do 32 divided by -16, and that will leave us with -2 because we're dividing by a negative, which is good because we need it to match the q minus 2 on the other side. So one of our factors is q minus 2, and the other one is q squared minus 16. Now this would be a possible answer, but this is not factored all the way. So you could factor this one a little bit more. So sometimes it says factor completely. So let's practice that, because this guy here is a difference of squares. Difference of 2 squares. So that can factor into q minus 4, q plus 4. So we got q minus 2, and then q minus 4, q plus 4. So that would be our final answer there. Because this guy here factored into q plus 4, q minus 4. All right, number 9 is another factor by grouping because we've got 4 terms. Put your dotted line down the middle. These 2 terms, 10 and 2, are both divisible by 2, so our GCF is going to have a 2 in it. We also have a d squared in both terms, so we'll pull out a d squared. And that will leave us with the first term with just a d left when we pull out d squared. 10 divided by 2 is 5, so we'll have a plus 5 here, and just that because we pulled out the d squared. On the right-hand side, 3 and 15 have a common factor of 3. We're going to pull that plus sign out with the 3. When I factor 3 out of the 3d, I'm just going to be left with d. When I factor 3 out of 15, I'm dividing by 3, so I'll get 5. And that'll be good because that'll match the d plus 5 over there. So one of our factors is d plus 5, and the other one is 2d squared plus 3. Another factor by grouping here. Put our dotted line down the middle. On the left-hand side, no numbers in common, but they both have at least an x squared, so our GCF is an x squared. Pull an x squared out of x cubed, and we're just left with a single x. Pull x squared out of minus 6x squared, and we're just left with minus 6. On the right, 9 and 54 have a common factor of 9, but we're going to pull that negative out with that 9. So that negative is going to come out with that 9, so that'll leave us an x for the first term, but 54 divided by -9 will leave us a -6. So now those match, which is good. So we'll have x minus 6 and x squared minus 9. Now we could possibly leave our answer here, but if we are asked to factor it completely, we should keep going, because this right here is another difference of squares, difference of 2 squares. X squared and 9 are both perfect squares, so we can keep going. So we still have our x minus 6 in the front, but then the x minus 9 squared can become x minus 3, x plus 3. And so then this is our final answer. All right, another factor by grouping here. Put our dotted line down the middle. 9 and 27 are both divisible by 9, so that's going to be part of our GCF. We have a w squared in common on that side. When we pull out 9w squared, we'll be just left with a w in the first term. 27 divided by 9 is 3, so this will be -3. and the w squared came out, so no w. On the right-hand side, we have 4 and 12. 4 is a factor of both 4 and 12. We're going to pull that negative out that's in front with the 4. And so we'll have just a w left in the first term, but when we do 12 divided by negative 4, when we factor out that negative 4, we'll be left with a minus 3, which is good because it matches that w minus 3 over there. So then we'll have 9w squared minus 4 times w minus 3, which we might be done, but we're actually not. This one is also a difference of 2 squares, so we can keep going with that one. So we'll keep our w minus 3 from here, but then our 9w squared minus 4 will factor into 3w minus 2 and 3w plus 2, because that's a difference of 2 squares. So that's our final answer, because this guy became 3w minus 2, 3w plus 2. All right, we have another one here with a in the front. So we have to be careful here to make sure to do this. So we start by multiplying the 6 and the negative 10. That gives me negative 60. So we're going to look for two numbers that multiply together to get negative 60 and add together to get negative 11. 6 and 10 multiply together to get negative 60, but one's going to have to be negative because the 60 is negative, right? So 6 times 10 will only make negative 60 if one of those is negative. If I put with the negative with the 6, that'll be 4. If I put the negative with the 10, that'll be negative 4, and I want negative 11, so that does not work. So let's look at what our other options are. 60 is divisible by 5 because it ends in a 0, so let's see. 60 divided by 5 is 12, so 5 and 12 is another option. One of them is going to have to be negative because we get negative 60. If I make the 5 negative, I get 7, and if I make the 12 negative, I get negative 7, and that's not good because I want negative 11. So let's see what else. 60, let's see if it's divisible by 4. It is. 4 times 15 is going to give you 60. If I make the 4 negative, I get 11. Oh, we're getting close, but I want negative 11, so that means my 15 needs to be negative. So remember, once you find those numbers, you're going to come in here and replace the middle term with those numbers. So you'll have plus 4y and minus 15y. Keep your minus 10 on the end. And then you're just going to come back and do factor by grouping. 6 and 4 are both divisible by 2, and we have a common factor of y, so we'll factor out 2y. That'll leave us with 3y plus 2, sorry. When we divide 6 by 2, we get 3. When we divide 4 by 2, we get 2, and we'll have a y left when we pull out y out of y squared. On the right, 15 and 10 are both divisible by negative 2. No, 15 is divisible by 3 and 5. 10 is divisible by 2 and 5, so negative 5. Remember, there's a negative in the front here, so we're going to pull out that with the number. 5 is the common factor there. Negative 15 divided by negative 5 will be 3y, and